half would have essentially the same properties as the whole stone. I'll call this as an atomos. Yeah, atomos.
The word atom comes from the ancient Greek adjective atomos, which means undivided. The Greek philosopher Lysippus of Miletus and his student Democritus had the idea that all matter in the universe was made up of tiny invisible particles or atoms. Democritus believed that all atoms differed in size and shape, were in constant motion in a void, and were colliding with each other, and during these collisions would rebound or stick together. Therefore, the changes in the states of matter could be explained by the dissociations and combinations of atoms as they move throughout the world.
Hey guys, look at this. I found the atomic theory model.
In 1805, Dalton put the puzzle together and developed an atomic theory. He proposed that an atom is like a tiny impenetrable ball. Dalton's atomic theory contained a few assumptions. All matter is made up of atoms. Atom is indivisible and indestructible. All of atoms in one element are exactly the same, but they are different from other atoms of other elements. John Dalton's atomic theory was generally accepted because it explained the laws of conservation of mass, definite proportion, multiple proportion, and other observations. Although the exceptions of Dalton's theories are now known, his theory has endured with modification throughout the years.
Please explain about categories.
But first, what is your knowledge about category?
I just thought that categories when rays or waves at all were in fact very light, very small, and negatively charged particles. I'll call them corpuscle.
We call corpuscle as electron. Thomson discovered and measured that the mass to charge ratio of an electron and discovered that the mass of electron is 1,800 times smaller than the hydrogen, which is the smallest atom. These corpuscles were particles unlike any other previously known, so even though we didn't understand what shape they took, we knew that there were both positive and negative components to matter.
How are they arranged in the atom?
Thomson suggested that atoms are divisible and the corpuscles were their building blocks. We knew that an atom consists of positive and negative charge. Thomson proposed that the corpuscles were distributed uniformly in a positive charge. We call this as plum pudding model, as the electrons were embedded in a positive charge, like plum in plum pudding.
In 1911, Thomson's plum pudding model was disproved by one of his former students, Ernest Rutherford, who discovered that most of the mass and positive charge of an atom called proton by designing an experiment using an extremely thin sheet of gold foil and a screen coated with zinc sulfide. He bombarded the sheet with alpha particles and he expected them to just fly right through the foil with no deflection. But some of the alpha particles experience heavy deflection. But Ernest Rutherford's model was not complete as it could not account for all the mass of an atom. However, in 1913, Niels Bohr, who is one of Thomson's students, expanded on Rutherford's nuclear model and developed a new model of the atom known as Bohr model.
From this, I can suggest that protons form a small central nucleus around which the electrons revolve. Almost the whole mass of the atom is contributed by the nucleus. The number of protons is equal to the number of electrons in an atom. Electrons move at a high speed around the nucleus at different distance from the nucleus. And this is the model of atom. Hey Ifa, look at this. What is that? This is atomic model. Oh. Do you know, the atomic theory has been further enhanced by the concept that protons and neutrons are made of even smaller unit called quarks. The quarks themselves are either made of relative strings of energy. The theory of the composition of the atom continues to be an ongoing and exciting adventure. Today, we are extremely confident that the quantum model is correct. However, the only way we can go on being sure is to keep asking questions and conducting experiments. Oh, thank you for the information. Okay.
In 1932, James Chadwick discovered that the neutron, which is an uncharged dense particle that also resides in the nucleus by bombarding beryllium atoms with alpha particles. Neutrons are located in the center of an atom in the nucleus along with the protons. They have neither a positive nor negative charge, but contribute the atomic weight with the same effect as a proton. With the discovery of the neutrons, an adequate model of the atom became available to chemists.